Hello Trailblazers, 8th graders. I am again combining two videos in one because they're short, and I don't think you want to watch 4 videos this week. So let's get started with models and systems. Plus, this is all a review of stuff you had last year. So why do scientists use models? So we know that models are representations of an example of a process or a process. So a globe is a model of the Earth. So we use it because, especially back in the day, we couldn't go out and zoom out and look at the Earth. Now we can. That's costly and expensive. But we're going to use a model of Earth to teach concepts to understand how the world works. So models are used to test ideas about something we observe. Or cannot observe directly, I should say. For instance, we can't see how atoms work well. I mean, we can't see inside of an atom. We can see a lot more than we could 10, even 5 years ago. But we can't see all the small particles in those interactions. So we make atomic models to help us see that. That's on the micro level, or really actually much smaller than the micro level. On the macro level, in the big world, is like we can't, exactly see how the universe is happening. So do we make models of the universe to help us understand it? Absolutely. So models are used to represent systems. So a system is a group of parts that work together to carry out a function. Your body is a system to help keep you alive. It's made up of your organ systems, which if you break that down, smaller organs, smaller than that tissues, smaller than that become cells, and so on and so forth. If we look at it on a bigger level, Earth is a system made up of air, life, water, ice, rock. Alright, so going back again, you learned the 7th grade, but let's just review. All systems have at least one input, one process, and at least one output. So an input is a material or energy that goes into the system. So my example, what is the input? There's different inputs you could look at the toaster. You could say that input is the electricity going in that helps convert electricity is going to be turned into heat energy to toast the bread. You could also say the bread itself is the input. So many systems can have more than one. So I said they have to have at least one, but generally they have more than one. The process here is we're talking about energy. It's that electrical energy being converted into thermal energy, which is toasting the bread. The other process you can say is the actual toasting of the bread. The output, so the toaster is going to give off heat. If you've touched the toaster after it's gone through the process, it's not cool, it's hot. So that's one, heat energy. Another output is the toasted bread. Feedback doesn't always occur, but it's an output that changes the system in some way. So for a toaster, there is feedback, and it's when the toast reaches a certain temperature, there is a part of the toaster in there that records that heat. And when it gets to a certain point, it stops toasting. And so that feedback is going to change that system because it stops the process. Not all systems have feedbacks, but many do. So scientists build models, like we said, to represent a process. They test whether their input and output from the model actually matches what's happening in the natural world. So to understand tornadoes, to understand hurricanes, to understand all those natural phenomenons, we make generally computer models, not really tangible models like this cute picture shows us, so that we can test it. We do this when we build cars, we do this when we build computers, we do this when we design medicine, we do this almost in every aspect of the science. We are going to want to make a model, and we want to see if our model functions the way we see it working in the real world. Okay, so a simple model is got few parts or steps. Toasting bread is very simple. That's a simple system. A complex system is different. There's many parts. There's many variables. So when we talk about complex systems, we generally don't look at the whole picture. We look at just the specific part that we wish to study. So if I was, there's different people that study hurricanes. If I am on the ground in New Orleans and I am a geologist and I probably want to study how the levees are going to be affected by water. Now that's probably much different from a scientist who works in the oil rigs in the Gulf who is concerned about how rising sea levels could affect the oil rig. So it's the same system, it's a hurricane, but the different scientists are going to be looking at different aspects of it. Therefore, they're only going to be studying specific parts of that system. All right, so when we make models, we have to make assumptions based on the input and output from the natural world. So then we also make assumptions to simplify the model. So if I look at a food web, that is a pretty simple model. I'm going to assume in the food web that the lion eats a zebra. I'm going to make that assumption based on the input and output that I observe. I'm going to assume that the baboon eats the grass and the baboon does not eat the lion. So my point is that when we make assumptions, we have to go back and test them. Then I would go out, after I made my model of my food web, maybe I would make some observations in the savannah for a few weeks, and I would be backed up in my initial assumptions. All right, that's it for that one. But there is one more that I want to go through. So let me find that one real quick. Bear with me. All right, so this one's about scientific theory and law. Again, a review of things you learned last year, but we have to go over it. So let's get started. So a theory is a well-tested explanation for a wide range of observations and experimental results. Theories become better accepted as they help to explain more and more observations. Theories go through changes. So, for instance, we're going to learn later in the year that the theory of how the universe was is very different than what it is now. So back when man first started understanding about planets and the sun, we believed in the geocentric model of the universe. First of all, we didn't know there was anything other than the planets we could see in our solar system and our sun. So we just thought that was the universe. And we believed that all objects revolved around the Earth. That changed with some very forward-thinking men, and they said, no, that's not true. The Earth and all the other planets revolve around the sun. We then came to understand, as our science got better and we could see farther out in the universe, that there was many more things out there than just us. And we began to develop theories on how the universe was or where it originated. And so we now believe in the Big Bang Theory. That's how all these things came to be. So theories are able to change. So flamingos, let's talk about this. Flamingos, we see pictures, look, that dude's just chilling on one leg. For a long time, researchers had no idea why flamingos stood on one leg. Is it because flamingos are able to balance better on one leg? Is it because fewer ducks bump into them when they stand on one leg? Or is it for another reason? So I know that sounds crazy. Why would people spend time worrying about flamingos? But, if you're an ornithologist and you your specificity is in flamingos, and you probably do care why they stand on one leg. So in 2009, researchers finally believed they found their answer. Flamingos are better able to control the temperature of their body when they stand on one leg. So the dealio was with most animals, us included, is that our organs, so our major organs are in our torso, and then of course our brain. That's really important that we, regulate our body temperature. So our limbs, our legs, our hands, our feet aren't always as warm as the rest of our body because they don't contain vital organs. And quite frankly, if you lose a limb, you still can enjoy a fruitful life. Whereas if you are missing a part of your torso where your organs are, you significantly lower the chance of having a fruitful life. So flamingos want to control their body temperature. Look how long and skinny their legs are. So by pulling that one leg up, he's able to, regulate and control his temperature better because he's not worried about sending a ton of blood down to that limb to keep it warm. Interesting. All right. Laws are a lot different than theories, and I know sometimes for you guys it's hard to understand the difference, but laws are statements that describes what scientists expect to happen every time under a particular set of conditions. It doesn't say why. So for example, the law of gravity, it just says what goes up must come down. That's a very simplistic explanation of the law of gravity. It doesn't say why that occurs, it just says that it does. So laws don't change. Laws are something we've been observing since the beginning of time when we became cognizant beings, and they aren't changing. So theories are able to change because we get more and more understanding of the world around us. Laws are just pretty much set in stone. So again, this is just going to back it up. Scientific theories attempt to explain observations and results from experiments. So we're explaining with theories. Why is the universe there? Well, the Big Bang Theory explains why. Well, there was this, the singularity, and all the matter and energy that are in the world today came from the singularity, so on and so forth. Laws describe an observed pattern in nature without attempting to explain it. So when you're faced with having to tell the difference between the two, ask yourselves a question. Does this statement provide an explanation for why an event or process is happening? So the law of conservation of mass just says that mass/matter cannot be created or destroyed. It can only be transferred from one form to another. Does it explain why? No. Atomic theory, on the other hand, has evolved and changed over time as we have come to make more and more observations of how atoms interact in our world, and it does explain why there's protons and neutrons and electrons and why they interact the way they do. All right, so let's look at my things and talk about whether they're, and you don't have to write this down, this is not homework, but let's look at the different theories and laws that are up here. So what you can't see, sorry, it's cut off on my screen, is on the top right, it says an object in motion tends to stay in motion, and it's pointing to the shuttle. So is that a law or a theory? Does it explain why it's happening? So that's the law of inertia, okay? The one on the bottom left, all cells are produced from other cells. Where do cells come from? They come from other cells. It's an explanation. That is cell theory. Next one, bottom right, with the cute little meerkats that you can't read fully, I apologize, says physical traits from animals are passed from parents to offspring through units called genes. Okay, and this is, doesn't explain, this one is the, sorry, I had another teacher come into my room. I had to pause for a minute. So this is a theory of inheritance, or how things are passed from it. So it does explain physical traits. Where do they come from? Well, they're passed from parent to offspring. How are they done? How is that done? It's through units called genes. So the difference, remember, we see that theories explain. They do change over time, where laws, that's been happening since the world's been spinning. Oh, I thought I was done. I think I got one more. All right, so scientific laws, like I said, explain easily observed events. Scientific laws become widely accepted pretty quickly. But scientists only accept a theory when it can explain important observations. If a theory cannot explain new observations about the original area of study, then it is changed or thrown out. So theories change all the time, and laws generally aren't disputed whether you believe, you're heavily scientific or not. Whereas theories vary widely from different societies, from different cultures, different communities, even different scientists disagree on theories. So know that theories change, laws don't. All right, and that's it for this week. Hope you guys have a great day.